Welcome back to Through Inquisitive Kids. In this video, we will be applying unary linear inequalities to word problems and understanding the real-life relationships different inequalities may represent. This is part 2 of our fourth lesson, one-variable inequalities and linear functions. The two learning goals for today is to solve word problems by modeling using unary linear inequalities and classifying and discussing ideas in solving word problems with inequalities. Review and think. Solving word problems using equations. When we were back learning about linear equations, what were some of the steps when we used them to solve word problems? Well, we always started with a word problem. And the first thing we did after that was to set the variable. After finding the equivalent relationship, we could write the equation, solve the equation, and then finally answer the problem. Inequalities aren't that different. A lot of the things you have to do, such as combining like terms or transposing terms, it's kind of the same as solving word problems with equations. You still have variables and you still have to find quantitative relationships, only that this time it may not be equivalent relationships. Throughout this unit, we've been comparing the knowledge we've been learning about inequalities with the knowledge we already have about linear equations, and this lesson is no different. Translate the following phrases into mathematical symbols. Exceed, at least, and at most. Well, these phrases can all be represented by the greater sign, the greater or equal to sign, and the less than or equal to sign. When we were learning about linear equations, we learned how to find keywords such as is equal to, is the same as. Those are all tools that help us find the equivalent relationship. And in word problems involving inequalities, we're going to see keywords such as exceeding, at least, and at most, or no more than, or no less than. So it's really important that you're able to understand what these keywords mean and then find the quantitative relationship based off of these phrases. The application of unary linear inequalities. Condon plans to go hiking with his friends on Sunday. They're starting at 7 a.m. and are planning to rest for 2 hours after reaching a summit. They must return to their starting point by 4 p.m. If their climbing speed is an average of 3 kilometers per hour and the downhill speed is an average of 4 kilometers per hour, what is the furthest possible summit climb? Here we see the diagram of Carmen and his friends going hiking, and we see that there are 4 different destinations they can choose to go to. Summit A, which is 7 kilometers away. Summit B, which is 8 kilometers away. Summit C, which is 13 kilometers away. And Summit D, which is 11 kilometers away. So we're just trying to help them find the furthest possible peak they can travel without exceeding these time limits. Well, let's solve this together. So we already have our problem, and we have our variable, which is kind of what we're trying to solve for. Now we have to find the quantitative relationship. What is the quantitative relationship here? Well, let's highlight some words that could help us determine the quantitative relationship. They are starting at 7 a.m. and are planning to rest for 2 hours after reaching a summit. Okay. They must return to their starting point by 4 p.m., which means no later than 4 p.m. And the furthest possible, which means not exceeding, but the furthest possible summit climb. So these are 2 phrases that tells us kind of the gist of what symbols to use. Our quantitative relationship is here. The time that we take to go uphill plus the time we take for 2 hours on the top of the summit and the time we take to go downhill has to be less than or equal to the total time limit. And this total time is the time we have from 7 a.m. to 4 p.m. So here is our solution. Let the distance from the starting point to the summit be x kilometers, meaning that the time spent in going uphill would be x thirds of an hour, and the time going downhill would be x fourths of an hour. Since we know that they rested for 2 hours, and the difference from 7 a.m. to 4 p.m. is 9 hours, so their entire trip should be at most 9 hours. From this, we know that x divided by 3 plus 2 plus x divided by 4 can be no more than 9 hours, which we can represent with less than or equal to 9 hours. After solving, we have x is less than or equal to 12. Therefore, the furthest Common and his friend can go while meeting all of the requirements would be Mount D. And how do we know this answer? Well, our solution would be x is less than or equal to 12. And let's look at the diagram here. Which of these is less than or equal to 12, but is the greatest possible one? Well, 13 can be eliminated because that's greater than 12, which leaves us with 7, 8, and 11. And then now out of those, we want the greatest possible one, which would be D. Remember, we can't say Common and his friend can go to a mountain 12 kilometers away. No, because that's not what the question is asking. We're trying to choose out of these options. So a lot of the times when solving word problems like this, be sure to check if your solution really answers the question. Maybe there's another step after that. Maybe you have to do something else with your solution, or maybe it doesn't make sense. So it's always good to check and evaluate your answer before answering. Let's do another problem using the same steps. The purchase price or the cost of a certain product is $200, meaning that they bought this product with $200. And now that they're selling it at a sales price of $300. The shopping mall stipulates that it can be sold at a discount, but the profit margin cannot be less than 5%. Please help the salesperson to calculate at what discount can this product be sold at. Now I just want to go over a lot of vocabulary. We have actually gone over all of these vocab words in our previous units and maybe in the previous grade level, but some of you new viewers here may not be so familiar with these financial terms, so I'm just going to quickly go over them. First of all, just for real life, you should start learning some of these key words. And if you're going to start your own business or something, this is probably a good skill to have. And also, when solving lots of math problems, you may know the actual math, but you don't understand the financial part, which can allow you to be a bit confused. So I'm just going to go over these vocab words. First, what is purchase price? Purchase price can also be the cost, which is the money spent to buy this product, spent on imports. So say you were to sell a bracelet, but you didn't make it yourself. So its cost, say, would be $5, and then you would sell it for $10 to get a profit of $5. The cost is just how much you yourself buy the bracelet with, or the product. What is sales price? Well, the listed price would be before the discount, what was the price? But the sales price would be after the discount, what is the price it is actually sold at? The profit margin, this is probably the one that many people are confused about. What is the profit margin? Well, I suspect you already know what profit means. The amount that you gain after your expenses. The profit margin is equal to the profit divided by the cost. So how much of your cost did you gain back? Okay, so now that you know all of these vocabulary words, let's look at our analysis. The quantitative relationship is the sales price minus the cost divided by the cost is greater than or equal to our profit margin. So here's a solution. Let the discounted sales price be X%. So the inequality we can write would be 300 times 0.01 x minus $200 divided by $200, remember that's the purchase price or the cost, has to be greater than or equal to 5%. Some of the keywords here would be cannot be less than. Solved, x is greater than or equal to 70. Our answer would be that this product can be sold on a discount of 30% off. Remember, it's not 70% off, it's 30% off because you're paying at 70% of the original price. Another question. There are 25 questions on a test. Each correct answer earns 4 points, while each incorrect or blank answer deducts 1 point. One student was identified as outstanding by having 85 points or more on their test. How many questions do you have to get right at least to become outstanding? So the keyword here is 85 points or more. So it's not saying less than 85 points. You can have 85 points or more on your test. Now, what is the quantitative relationship? This is pretty basic. It's just that your total score has to be greater than or equal to 85 points. Let the student answer X questions correctly and answer 25 minus X questions incorrectly. Oh, and what this person did smart right here was instead of writing another variable for the amount of questions answered incorrectly, say writing down the variable Y, they just wrote down 25 minus X. You usually want to have as less variables as possible to make it easier to solve. Anyways, our inequality would be 4x since you gained 4 points for each correct answer, minus 1 times 25 minus x since you deduct 1 point for every incorrect answer or unanswered question, and all of these points added together has to be greater than or equal to 85 points. Solved, this can be simplified to x is greater than or equal to 22. So you must answer at least 22 questions correctly in order to be marked as outstanding. When a person sits down, lifting a heavy object exceeding 4.5 kilograms has some risks to injury. Kanban is sitting at his desk and wants to move 2 textbooks that each weigh 1.2 kilograms and some notebooks that each weigh 0.4 kilograms. How many notebooks should he move at most? Now that we've already went over 3 problems together, I want you to start following these steps. So you have the word problem, and then I want you to mark the keywords, and then set up inequality, and then you answer. So these are kind of the 2 things I want you to focus on. All right, so what answer did you get? I'm going to erase this drawing just so we can have more space. All right, so what was your keyword? It says that exceeding 4.5 kilograms has some risks to injury. Exceeding. Remember, this was one of the keywords we went over at our review slide at the very beginning of the lesson. Exceeding, which means greater than. And now, we have the 1.2 kilograms each, 0.4 kilograms each. These are the numbers that sometimes I like to circle. So the quantitative relationships we get is that the weight of the textbooks plus the weight of the notebooks has to be less than or equal to 4.5 kilograms. So let Common move X notebooks. That's the thing we're trying to find, so that makes sense to make it a variable. Now, according to the quantitative relationship, we can write down this inequality. 1.2 times 2, because he's moving 2 textbooks, plus 0.4x is less than or equal to 4.5. Solved, x is less than or equal to 5.25. But now this is where our logical thinking really has to come in. Can you really move 5.25 of a notebook? No, that doesn't really make sense. And since this is a word problem, you can't answer with 5.25. Which means that you have to really do a bit of thinking. Since there can only be a whole number of notebooks, the greatest value of x would be 5. Again, you can't have a negative number of notebooks either, so it doesn't make sense to have -1 or -2 or anything like that. So our answer would be Common can move 5 notebooks at most. So here's our conclusion. Here are the steps of solving word problems using inequalities. We start with a word problem, and then with finding relationships and setting the variable, we can write down our inequality. Solve the inequality, and after checking the reasonableness is when we truly answer the question. Now this step, lots of people just skip. You might get ahead of yourself, but please don't skip this very critical step because this usually means the difference between a good student and a truly great student. Alright, so you finally got to the end of this video. Today we did do a lot of practice work with our word problems and reviewing the steps of solving word problems using algebra. So here is our class summary. Today we applied unary linear equations to word problems. And we learned about the steps. So word problems, finding quantitative relationships, solve the inequality, and then checking the reasonableness of the solution. Finally, we get our answer. The two skills that we learned today is to solve word problems by modeling using inequalities and classifying and discussing ideas in solving word problems with inequalities. Thank you so much for watching through Inquisitive Kids, and we'll see you next time.